Welcome to Fast Track Math. Ever wonder why some functions have limits on what x can be? In this quick lesson, you'll learn how to find the domain of any function, linear, quadratic, radical, or even rational. So what is a domain? The domain of a function is all the possible input values, that is x values, that make the function work without breaking math rules. So you can plug in any x that doesn't make the equation undefined, or take the square root of a negative number, for instance. So think of it as the allowed zone for your input values. So once again, the domain is all x values that work in the function. So first, let's talk about linear functions. Linear functions are functions of the first degree, and their graph is a straight line. So for example, if we have the function f of x equals 3x plus 5, we can see that this is a straight line and our y-intercept is 5. It crosses the y-axis at 5. So here the rule is there are no restrictions. Really, you can plug in any real number for x and your function will still be defined. Therefore, the domain is all real numbers. X can take values from negative infinity to positive infinity. Now how about quadratic functions? Quadratic functions are functions of the second degree, and it will have the form f of x equals ax squared plus bx plus c. So for this example, we have the function f of x equals x squared minus 4x plus 3. As you can see the graph here, it's an upward parabola. And you can plug in any values for x and the function will still be defined because we can square any number. So there are no restrictions here. Once again, the domain is all real numbers. X can take any value from negative infinity to positive infinity. Now let's talk about cubic functions. Cubic functions are functions of the third degree. So for this example, we have f of x equals x cubed plus 2x minus 5. We can see the graph here of the function. And cubing also works for any x. Therefore, the domain will be all real numbers. So x can take any value from negative infinity to positive infinity. If you like what you see so far, please like this video and subscribe for more. It really helps our channel. Now let's talk about radical functions. So in this example, our radical function is f of x equals square root of x minus 3. The rule here is that you can't take the square root of a negative number. So in this case, we'll have to set up what's under the root, that is x minus 3, to be greater or equal to 0 because that can't be negative. So solving for x, we'll need to add 3 on both sides of the equation. Therefore, x is greater or equal to 3. And that is our domain. Our domain is from 3 included to infinity. And if we look at the graph of the function, you can see that it starts at x equals 3 and then it goes on to infinity. So once again, the rule for radical functions is that you cannot take the square root of a negative number, or any even root for that matter. If you have an even root, you can't take whatever's under the root cannot be negative. Now, how about rational functions? In this example, a rational function is f of x equals 1 over x minus 2. So the rule here is that the denominator cannot be equal to 0 because you cannot divide by 0. That will make your function undefined. So in this case, we'll set x minus 2 to be not equal to 0. So in order to solve for x, you will add 2 on both sides. Therefore, x is not equal to 2. So the domain is all real numbers except for x equals 2. So my domain will be from negative infinity to 2, not included, union from 2 to infinity. And once again, we use a parenthesis that shows that 2 is not included. And if we look at the graph of the function, we can see that the function has a vertical asymptote at x equals 2, creating two separate branches. So once again, for rational functions, the denominator can never be 0. Therefore, values of x that make the denominator 0 have to be excluded from the domain. Now let's look at a mixed function. We have f of x equals square root of x minus 1 over x minus 4. So in this case, we have a radical function within a rational function. So step number 1, we'll look at the square root restriction. So we know that inside the square root has to be greater or equal to 0. Therefore, x minus 1 has to be greater or equal to 0. And solving for x, if we add 1 on both sides, x is greater or equal to 1. So that's our first restriction. I know that in our domain, x has to be greater or equal to 1. Then, let's look at our denominator. We know that the denominator can never be 0. So x minus 4 cannot be equal to 0. In order to solve for x, we add 4 on both sides, and therefore x is not equal to 4. So if we combine the two restrictions, I know that my domain has to be greater or equal to 1, and 4 is excluded. So I'll start at 1 included, that's why we use the bracket, to 4, parenthesis, because 4 is not included, union from 4 to infinity. And if we look at our graph, we can see that it starts at x equals 1, and then there's a vertical asymptote at x equals 4, because the function is not defined there. So if you have a mixed function, you need to make sure that you apply all of the rules, the restrictions, in order to find the domain of that function. Let's look at one more example. Let's say our function is 2x minus 1 over x squared minus x minus 6. So this is a rational function. So we know that the denominator can never be 0. So we'll need to find values of x that make the denominator 0 and exclude them from our domain. So first, let's factor the denominator. X squared minus x minus 6 is the equivalent of x minus 3 times x plus 2. Using the FOIL method, you can check it. X times x is x squared, x times 2 is 2x, minus 3 times x is minus 3x. If you combine the two middle terms, that is minus x, and negative 3 times 2 is negative 6. So therefore, we know that our factorization is correct. Now, we're going to set a restriction. If either one of our factor is 0, then the product will be 0. So let's set first x minus 3 to not be equal to 0, because that's the restriction for rational functions. The denominator cannot be 0. And then we'll set x plus 2 not equal to 0 as well. Solving for x, if we add 3 on both sides, x is not equal to 3. And subtracting 2 on both sides, x is not equal to negative 2. Because these two, x equals 3 and x equals negative 2, would make the denominator 0. So therefore, x equals 3 and x is negative 2 have to be excluded from the domain. So my domain is therefore from negative infinity to negative 2, not included, union from negative 2 to 3, not included, union from 3 to infinity. And if we look at the function, we can see that it has two vertical asymptotes, one at negative 2 and another one at x equals 3. So these two numbers are excluded from our domain. So here's a recap. For linear function, there are no restrictions. The domain is negative infinity to positive infinity. For quadratic and cubic functions as well, there are no restrictions. The domain is negative infinity to positive infinity. For a radical function, if you have the square root or any even root, what's under the root has to be greater or equal to 0. So usually your domain will start at a particular value to infinity. And then for rational functions, the rule is that the denominator cannot be 0. So you will exclude values of x that would make the denominator 0. So now here's your challenge. I want you to find the domain of the function f of x equals square root of x plus 5 over x minus 1. And drop your answer in the comments below. Now you can find the domain of pretty much any function. No guessing. You've learned how to handle linear, quadratic, cubic, radical, and rational functions with confidence. Thanks for watching. Please like and subscribe. And don't forget, math success starts when you stay on the fast track.